Hi, in this video, we will see JVM. So Java Virtual Machine. So what do you mean by Java Virtual Machine in Java? So how a typical Java program executes, we need to see, right? So let's assume we have written a Java program called sample.java. So what do you mean by .java? Java is an extension to a Java program. If you write a Java program, how we'll make sure that is a Java program? So the file name should end with means the extension of file will be .java. So here the file name is sample, as it is .java is a Java program, it's Java file. So that is called source code. So let's assume we have written a program called sample.java. Java compiler compiles the source code to sample.class file. Means when you compile that sample.java, it will generate a bytecode, and the bytecode will be sits in where that is a separate file called dot class with the same name with the dot class extension. That is called bytecode. So sample.java will generate sample.class once you compile the code. This compiled file can be executed in any platform by JVM, Java Virtual Machine. So that we discussed in our previous videos also. So once you get that bytecode, JVM will execute this in any platform. Okay, so the bytecode will be executed by JVM. So the purpose of JVM is to execute the bytecode. So JVM translates bytecode into native machine or platform code which machines can understand, execute. Okay, so bytecode is not understandable by our machine, means Windows or Mac or Linux. That machine cannot understand the bytecode. So how this machine can understand this bytecode? So that job JVM will do. It will convert that bytecode into machine understandable code and then execute. Okay. So JVM is a virtual machine that runs the Java bytecode. .java files can be compiled into .class files. .class file contains the Java bytecode understood by JVM. So bytecode is only understood by JVM. Now JVM is a specification that provides runtime environment which executes Java bytecode. Okay. So there are different types of JVM implementations are available by different vendors. So JVM can be developed, means is developed by so many other people, means vendors also, apart from what is a Oracle. Okay, so if you visit this link en.wikipedia.org/wiki/list of Java virtual machines, there you can see multiple Java virtual machines. You can use any one of those. So it is a diagrammatic means of JVM architecture. So diagram of JVM architecture. If you observe here, so JVM language classes and then class loader. From the class loader, say JVM memory. So inside the JVM memory, we have method area, heap, JVM language stacks, PC registers, native method stacks. So all this comes under JVM memory. So each and every will have their own purpose. Okay, then execution engine, native method interface, native method libraries. So this is simple diagram of JVM architecture. If you want to deep dive into this same architecture, so you see it looks like this. So .class file comes to the class loader subsystem. Inside this you have a loading, linking, initialization, and then this is runtime data area. In this you will have a method area. You see that method area, the simplest form here. You see method area, heap area, stack area. Inside the stack area, we have different threads. As we discussed, Java is multi-threaded, right? So thread 1, thread 2, thread 3, so thread n. So PC registers. So PC register for thread 1, thread 2, and means how many you have here, that many PC registers and native method stack. And then execution engine. Inside the execution engine, you have interpreter, JIT compiler, garbage collection, native method interface, and native method library. So if you deep dive into JVM architecture, you will see something like this. Okay, so we'll discuss each and every topic. Now, what we have seen in this diagram. So class loader. What is class loader? Class loader reads the .class file and saves the bytecode in the method area. So the class loader will load that bytecode into this method area. Okay, so that is the purpose of class loader. So what is method area? There is only one method area in JVM which is shared among all classes. So how many classes you have? You'll have only one method area. This holds the class level information of each class file. So it will have holds only class level information. So what is heap? Heap is a part of JVM memory where objects are allocated. We already discussed Java is a object oriented programming language. So we need to create objects. That objects are allocated in the heap memory. So JVM creates a class object for each class file. So JVM creates a class object, means it will create an object for each and every class. Okay. And then what do you mean by stack? Stack is also a part of JVM, like heap, but it is used for storing temporary variables. If you have any temporary variables, we will store in the stack area. So what do you mean by PC registers? This gives the track of which instruction has been executed and which one is going to be executed. So you have multiple instructions. What is executed, what should be executed can be taken care by PC registers. Since instructions are executed by threads, each thread has a separate PC register that we already seen here, right? So thread 1, thread 2, thread n, and the same way PC register 1, PC register for thread 1, and PC register for thread n. So native method stack. A native method can access the runtime data areas of the virtual machine. So if you have something to read from this virtual machine, so that can be done using native method stack. So interpreter. So a JVM interpreter pretty much converts each bytecode instruction to corresponding native instruction by looking up predefined JVM instruction to a machine instruction mapping. It directly executes the bytecode and does not perform any optimization. Okay, so if you want to say something like this, what do you say? So if you talk about this one, so you have your source code. This source code can be converted to bytecode. How it is converted? Using compiler, right? So then bytecode can be converted to machine understandable code. Okay, machine understandable. So this machine understandable code can be done by interpreter. So Java is compiled and interpreter code, right? Then you can execute this code. Then compiler means it will compile all the code at a time and convert into bytecode. Okay, compiler means the difference between compiler and interpreter is in the basic, the high level. Compiler converts whole code at a time and convert into bytecode, but interpreter will not interpret all the code at a time. It will interpret line by line. So this line interpreter and give the output, means understand machine understandable, then comes to this one, then comes to this one. So line by line it will do. That is the high level difference. If you dig into that, there are so many differences, but the compiler and interpreter basic difference is it will compile, means it will convert everything at a single, means one shot. But here interpreter, it will do line by line from the bytecode and it will interpret and it will execute. Okay, so that's how it will interpret the bytecode into machine understandable code and it will execute. So now the JIT compiler. To improve performance, JIT compilers interact with the JVM at runtime and compile appropriate bytecode sequences into native machine code. Typically, JIT compiler takes a block of code, optimize the code, and then translate it to optimized machine code. So basically, it improve the performance. It uses JIT compiler inside it. So this is all about JVM architecture. So That's how it will execute the code. So from here, what are the possible interview questions? Means you might face, can you explain what is JVM? Can you explain the JVM architecture? Otherwise, sometimes they'll ask what is the difference between compiler and interpreter. Okay. So that's all in this video. Thank you.